Why do things float? Well, based on the discussion we just had, we could say that specific gravity is maybe part of the story, right? Part of that story was that if something sinks, it has to do with the fact that the buoyant force is less than the weight of the object. If it floats or it is floating, it means the buoyant force is actually in balance with the weight of the object, and hence it won't displace a volume of fluid equal to its own volume. It'll displace less than that, right? Because some of it will be like sticking out, even if it's a little bit like an iceberg, right? Where most of it's still under the water because the specific gravity of ice is only slightly less than one. But it turns out there's a deeper answer to this. And so with this question, we can go a little bit deeper into like, well, okay, so we've got a bunch of math here, right? But what really, like, what's the force responsible? What kinds of forces? And well, we've said, well, it's the buoyant force, but just giving it a name doesn't really answer this question, right? What's really going on? Well, one of the things I mentioned is the buoyant force is based on pressure forces. And one of the things we already know is that pressure increases with depth. So that means that if you have an object that is surrounded by fluid, the pressure forces on the bottom of that object are at a greater depth, will be larger than the pressure forces at the top of the object. That represents an imbalance in forces, which means there would be a net upward force. And in a nutshell, that's why there is a buoyant force. So I have in this slide a picture showing some examples of that. We have an old style, I guess, sailboat or something like that, wooden boat. And it shows here that there are pressure forces on the bottom of that boat because it is in the water. And as you go to some depth, there's going to be pressure forces there. For a submerged object like this submarine here, there's going to be larger pressure forces on the bottom of the submarine than there are going to be on the top. Now, in reality, there'd also be pressure forces like pointing to the on the sides and so on, but I didn't draw those in here, I think, because what I was using, it was difficult for me to do that. But here's like a sperm whale, it looks like, right? And sperm whales can dive to quite amazing depths. And the pressure forces increase, but the buoyant force really relates to the difference in these pressure forces. So it turns out if you ask, like, is the buoyant force going to be significantly increased at a greater depth because the pressure forces are larger there? The answer is no. It's still going to be equal to the weight of fluid displaced. And since water is a largely incompressible fluid, that will be independent of depth. So it's really just dependent on the volume displaced. So if this submarine and this whale had the same volume, they would have the same overall buoyant force.